Hi, so we are going to proceed with practical 4.2, which is pattern heat initiated blast. So what's with this phi blast is we are using, we call this repeated amino acid alignment, the pattern, because this is a pattern that determine certain proteins. Like for example, in this practical 4.2, this repeated pattern, is for conserved region of lipases. So as you can see here, they are all repeated, but they are not exactly the same, right? This one. So what we do in order to design a pattern is we put a bracket and a non-bracket, which means if it's in the bracket like IL, so the alignment can choose either to be aligned with I or L, but the I without the bracket have to be exactly the same. So this is actually for alignment number 1, it's either I or L. Alignment, no, I mean like protein number 2, protein number 1, is either I or L, or protein number 2, it has to be I. Protein number 3, it can be A or G. For number 4 must be H, number 5 must be S, and so on. So we are using this repeated pattern in our query to compare with the databases in the NCBI and see any other sequences related to our query. So we're going to start. Let's just follow these things. Well, first access the protein sequence. This one, copy the accession number and paste it here, and just click search. So this one is for accession number for Geobacillus zalihae. Just click this one and find it until we see the translation protein. Where is it? This one. Here, translation. This one from M to P is a translated protein sequence, like mine is methionine and la la la. Let's copy and then paste this into the blast protein. Here we go. Set this one for protein data bank, and also fibroblasts. So it's not it. And then copy this pattern from our practical and paste it here. Click blast. Wait for some time. So here we go. These are the results. For the description, we have 34 sequences related. And also for evaluer residence ratio, we got just 3. So we don't have to do further iteration. We only have to do once. And we can take a look at the alignments. So this one is chain A, thermostable. This is the Geobacillus zalihae. As you can see here, this mark is our pattern. This also you can see for another strain, So we can see that this strain has repeated pattern. Same with our query sequence Geobacillus zalihi here. Then you can scroll down to further alignments. That one is just for example. Then we go back to the description and see this multiple alignment site. And take a look at this part. We will see the alignment. So as you can see here, take a look at this one from 87 until I think it might be like 20 sequences that has same repeated pattern as our query. Oh no. Our query is this one, IL It's been repeated here until G. See there? As I said before, that the first protein can be either I or L. So this one is I, and the second for this one is I, so it is I, and the third one can be A or G. So for this one it's an A, and it's an A. So H is low. Is H is there? Yeah, it's that H is being conserved here, like all until the sequence G, all the way until maybe like 20 sequences. So we can deduce that all of these numbers of sequences are related to our query sequence. Next, also for the number 7 of this practical 4.2, we have to design a new phi pattern based on this alignment. So what we do is take a look at here. This C, it's been repeated, right, until like the end of like here. So so it's convincing enough for us to design a pattern for us, a new pattern for us to redo the phi blast. So of all those repeated sequence, I have snip this thing. So we can see it's repeated C, E, A, blah 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 there. And however here C, it is not C. Here it is not C, but it is G. So what we do is we can design it like this for the first pattern. For the first amino acid, we can make it like this. It's either C or G. And then take a further look. All of it has the E. E are all the same. So we make it E compulsory. As mentioned before, if it is in a bracket, it can choose either to be C or G. But if it's not in the bracket, it has to be E. So we further follow. Take a look at the third amino acid. It's all A, but somehow we got L and Q and T. We can neglect this. So Then for the third one, we can use the ALQ. And for the fourth one, you see the Y all the way, maybe until here it's not Y, but we can Y and A, but we can just like play around with this thing. So what I did is Y and A, it is compulsory for the fourth and the fifth amino acid to be Y and A. And for the sixth, you can choose a QYA because it's QYA here. And then for the last one, as we are taking 7 sequences, so we can take I purposely use this because it's like I love you, right? So I Y L, so just what I L Y here. So this is our new design sequences, I mean pattern. So what we do is we repeat the steps. We paste, as in the first one, we copy the translated protein and paste it here, and then we change this to protein database, and then we pick the algorithm for fibroblast, but we change the pattern as we have already do it. It's CG, this one, right? So it's this one. And let me just click blast. Take some time, I'll just pause. So this are the result. So just now we have like 30 something. I think it's 33 sequences. But if we are using this one, this different pattern, like we start with CG instead of the one that's been on our practical 4. Our newly designed pattern shows a lower number of sequences with e-value better than threshold, and only one sequence with e-value worse than threshold. So we can see that so it's being more specific. Basically, it's being more specific to our query. So that's the end of the practical 4.2. So the pattern hit initiated blast is where we use some pattern like this one to align with the databases in NCBI using the protein data bank proteins PDB. If we just use the normal blast, the sequences might be too long or it might be not related. So as for this practical 4.2, we are interested only for the lipase conserved gene. So it's up to us.